Yes, so this RTK equipment I show you, with that you can put it anywhere on the ground, and then within centimeter accuracy, you can determine the position on the ground for that one. So what you do is, you fly around with your drone, but before you do that, you make markings on the ground. And here I'm going to show you some of those. So this is one such marking. As you can see here, it's loading. It's a lot of data, of course. But here you select in the center of this X, that's the number 233. And in the program, the web ODM, I can actually show that quickly. MITD, web ODM. Here we go to Vincent. So here you have a ground control point interface, but there's other programs for that. It's just, this is what I do. So here you select your drone imagery, your ground control points. Right now I have nothing to show because everything is processed already. But you basically zoom into the map here, and it shows you then where your ground control points are. And then here you have a list of photos, and then every photo, you click in the photo, poof, on that point, where on the photo you would see this at the center, and then you click here on the ground control point marker you have, and it connects that between hundreds of images, where you then say, on this image, this point has exactly these coordinates. On that image, that point has exactly these coordinates. And yeah, you can automate most of that actually, but there's always manual labor, of course. But the thing is, you do that for a point here, and then you do it for a point here, for a point here, for a point here, a point here. And well, what we do a lot of points. So usually I do 12 per grid here. So that's 1, 2, 3, 4, then somewhere in the middle, 5, 6, 7, 8, 9, 10, 11, 12. So that's how we would do the points here. And here the same, you try to always do them with the grid. The beautiful thing is you can then later process this and this at the same time, where then the ground control points from this and this, they aid each other in the accuracy. And then you do the next one here and the next one here. And when you do this one here, you use this as well. And when you do this one here, you use this as well. And then the more you get, you process more together, you group them together, and that aids in the accuracy. And for example, an area here, so this is Boesel watershed. This I cut out because the data here was not so good. So instead of having wrong data, I rather just cut it out. What you do then here for such an area with the trees, with a lot of greenery, then you take points here in the area where there's still residential. That's where you do your ground control points. Actually, the drone image itself we made here, it's much bigger. It's like this. It's much better, and we have ground control points here as well on these areas. But the thing is, towards the edges, the quality is not so good. So I always cut them out where the quality is not good. And we will cover that later when we extend our drone surveys. Then we add this and this. So I always make sure that our data is accurate. And the thing is, you don't need ground control points here in this area anymore. The points you have here in this area for the residential area around it or along major roads, that means here it's very accurate. You lose accuracy the further you go away from here, but for agricultural purposes, that's not so important anymore. Anymore. For agricultural purposes, it does not matter if you're at the boundary of your neighbor for like 1 or 2 centimeters, or if it's half a meter. So yeah, this is all forest area. For Baguio, I don't know how that is for you, but for Baguio, it's not important if this tree is positioned half a meter to the right or the left. That's not really important for us. For us, it's important where the buildings are. So the thing is then, if you have ground control points within 100 meters, then even green areas like this, they're still accurate within, yeah, let's say 10 to 20 centimeters accuracy. If this were 100 meter, it's not, it's only 20 meters, so we are still below 10 centimeter accuracy everywhere. But if the nearest ground control point is 100 meters far away, then you're looking at some 10 to 20 centimeters accuracy. Now the thing is, you're working here in QGIS, right? And I already auto-rectified the whole imagery using these ground control points. So what I said, when you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is completely auto-rectified. And then if you want to measure this area, you don't actually have to go in the field anymore. Let me show you what you can do here. You can add create layer, and then you say, yeah, you can use a virtual layer or a new shapefile layer. Let's make a temporary shapefile layer. That would then just be a file. Let's put it just in download for now, temporary. And then we say here the file encoding, yeah, we can use system file encoding, geometry type. Let's make that into a polygon. And then we say we want Philippine standard. Here we could add any field we would like to add, ownership, elevation, product, but we can also add that later. But let's say crop, we want a field crop here. Okay, so now we got here a temporary layer called crop, and then you just say, okay, I want a new polygon. And well, you can see here, it's a little bit around the trees, right? So I'm just going to do this very roughly now, just to demonstrate it. Anyway, if you're good at this, you will be better than I am. And then you say the ID, let's ID that one, and let's say the crop, that is sayote. Yeah, we can actually make it a bit more beautiful. Properties. Then let's say we want that hashed, and we want the color of the hash. Well, let's keep it a bit reddish, but not too reddish, right? And then as a label, let's say we just want a single label and we just want the crop as a label, right? Now you see it's very hard to read, so you can do a background here to make it easier to read, and a background to make it white. And they say, well, I want it a bit bigger, so you can actually then do it like that. Let's make it 15. Okay, then it's a bit bigger. Yeah, and then you can do, for example, here, the same here. You say again, 1, 2, well, let's say it goes up to here. This is another field, right? Okay, and then this ID, let's call that 2. But like I said, you can also add here new fields like owner or elevation or the status of the crop. If you have statistical information on it about the revenue, what you get from that field, or the growth efficiency, what's the English word for that again? Well, you know, if you maximize the kilograms you get per square meters, then you could get so much. Let's say you get 10 kilograms per square meter, but this farmer only manages 6 out of 10. Then you can give it a rating. All of that you can do there. But let's say this is crop, and let's say that is, well, I'm actually not sure what it is. Okay, let's call it lettuce, right? Just proof of concept. Yeah, and then you can do this very easily. And now the thing is, you got the perfect data for this. If you want to review the data, you can click here, and then you can add new fields, or, what's easier to do right now is you can simply click on the edit here, the vertex editor, and now you see all the coordinates in PRS 92 zone 3. So these are the official coordinates, and these coordinates, they are 100% accurate because of these ground control points which we put here on several places on the road. So you can actually zoom in. I know where they are. I know all the points in Baguio by heart. So this is another point, and the image which you're looking at, it's with the RTK rover, it's measured exactly at the point where I'm now pointing at with my mouse. And because this is very accurately measured within centimeters, here is another one. So this point here, again, exactly where I now put my mouse, that is measured. And because that is centimeter accuracy, everything you're looking at here on this drone imagery, it's centimeter accurate. And this is then how you can easily mark what is being done where on which part of the ground. So you don't have to go out there anymore. What you do is you have just one team who makes a few of these ground control points here. Then they measure with the RTK rover here. Then you fly with your drone over it, and that's it. Everything else here, you do that later in the office. All the other data which you want to put there, well, you just use the office. And if you say, well, but I don't have a 3D landscape, right? Oh, wait a second. I'm going to show you, because actually in Baguio we also have that. That's this one here, I believe, South Central. And then we say it's already point budget. So this is the same area. And we can actually zoom in to that same area. Let's click there. So now, yeah, this is point cloud, so it's a bit more data, but this is now 3D. So now you get a 3D perspective of what you're looking at. And that gives you then a good perspective now, because you see here how the river is flowing, the bridges, the slope here, you see the sayote growing. These are now the trees. So now you get this 3D perspective here, what for Baguio is very important, of course. And but again, this is rendering, so that's a bit more computing intensive. You need a bit stronger computer for that. But every single point what you see here, everything is accurate within a few centimeters of PRS 92. Here you can see, for example, horticulture, which is grown. So yeah, you can also map that then. You see the single individual greenhouses for the horticulture. You see here the agricultural production. So this is still in Baguio. We have also agriculture. Here you can see the river again, how it's flowing. Yeah, so that's basically the data we are working on here in the city. So the concept is we have surveyors, they go out there, they make these ground control points, then they fly the drone, then everything is digitalized, and then you have the mappers, and they work in the office, and they use this digital data, and that's what they use to map. So you have only few people who actually have to go out, and they can produce a lot of data, and everyone else can then focus on actually processing the data instead of wasting time on collecting the data.